Hi everyone, this is Jacob and it's finally Friday. Today we're going to go over the difference between aggregated MSDUs versus aggregated MPDUs. This is two different ways we can aggregate our data that is going over the wireless network. This will both speed up transmissions and conserve airtime. We're going to go over the differences between A-MSDUs and A-MPDUs and why you would prefer one over the other. So to do that, let's look at the overhead to a unicast frame. Whenever data is transmitted over the air, you get overhead in front of the data, which consists of a PHY preamble and a PHY header, along with a MAC header, and you get a trailer behind the data. And of course, each packet has to be acknowledged as well. Each data frame has to be acknowledged. So along with that comes a PHY preamble, a PHY header, and an acknowledgement. So we have quite a bit of overhead that's being passed over our networks. Therefore, the standard gives us a way to speed this up. The first being A-MSDUs. And what that does is it takes individual data units and packs them together into aggregated frames. With these frames, the overhead is reduced by only having one MAC layer overhead, and therefore the sender only has to compete for airtime once instead of multiple times, and are also acknowledged by one block acknowledgement. So we're cutting down our overhead tremendously there by both cutting down on the amount of bytes we're sending because of the lack of overhead, as well as the lack of having to acknowledge each frame individually. And then we also save the time it would take to compete for the medium again. So we know only one device can talk at a time, and if this one device can send this big data unit instead of multiple small data units, then it can compete one time, say what it needs to say, and then get off the medium, saving us our precious airtime. There is one downside to aggregated MSDUs, and that is the redundancy check is done on the whole frame. If any part of this frame is corrupted in transmission, then the whole frame will have to be resent. So that is the downside to an aggregated MSDU. Aggregated MPDUs are a little different. You get less overhead than a single frame. However, you get more overhead than aggregated MSDUs. This happens in a couple different ways. So aggregated MPDUs have less overhead than individual unicast frames, but more overhead than aggregated MSDUs. And this is because, unlike the MSDUs, every MPDU will have its own MAC header. So we're still saving on some of the overhead that is involved in transmitting multiple frames, because we get to send this all at once. We're not competing for the medium over and over again. However, there is inherently more overhead than the aggregated MSDUs. The benefit of an aggregated MPDU versus MSDUs is that the redundancy check is done on an individual MPDU basis. So if one of the MPDUs are corrupt, you don't have to send the whole frame again. You can send just that individual MPDU, saving you time on your retransmissions. So the majority of vendors will use MPDUs instead of MSDUs for this reason, because it is much more resilient due to noise issues than aggregated MSDUs are. So now that we have an idea of the differences between the two, let's look at how you would set it up in Extreme Wireless. So from within Extreme Wireless, you would come over to the APs. And there's multiple different ways you can do this. Like I've shown you before, you can click multiple APs, you can do a multi-edit, and you can scroll down to close to the bottom, and you can see aggregated MSDUs and aggregated MPDUs. You can do an individual AP at a time. And doing the same thing, you can see aggregated MSDUs, which is the faster way to send information, is disabled by default. And aggregated MPDUs are enabled. The last way you can do it is by going to your global settings, your default settings, and coming down and changing it this way. So we'll talk about it right here. You can either enable or disable aggregated MSDUs, and this is something that you will have to do a little bit of trial and error on. So before we talk about turning it on or off, I want to take you to the reports within the wireless controller really quickly, where you can go to your wireless stats and you can look at every AP and you can see the packet error rate as a percentage. Right now there's 0 errors on the 5 gig radio, and on the 2.4 there's also 0 errors. So the environment is pretty clean here. Therefore, we could probably go ahead and turn on MSDUs. 5 to 6% is normal. The 15% range is considered the max acceptable in a standard density environment. In a high density environment, you would be looking more at the 25% range. If you're ever over that, you would definitely not want to turn on aggregated MSDUs because it's going to slow down your network. But if you're below those percentages, if you're around the 5 to 6% range, then you can come in here, whether, like I said, do it your default settings or do a multi-edit. You can come in here and turn on the aggregated MSDUs. This will speed up your network. However, if you are having those issues, or if your environment changes and you start seeing a higher error percentage, then you can come back in and drop that back down, and your network will operate more efficiently. I appreciate your time. That's it for this Finally Friday. I hope you have a great day, and I'll see you next time.